Hi everyone, welcome back. Alright, so we are done with the first video, which we talk about the definitions of acid and bases according to three different theories: Arrhenius, Bronsted-Lowry, as well as Lewis. Okay, so the second video we discuss on how to calculate Ka and pH value for your weak acid and weak base, or using your Kb value. Okay, so the third video will not involve any calculation steps because everything involves explanation. We're going to talk about salts hydrolysis. Okay, by the end of this video, okay, you will be able to explain qualitatively about salts hydrolysis and classify the type of salts from the reactions. Okay, so either it's acidic or neutral or basic salts. Okay, right, so in this world, we have three types of salts that are present, okay, depending on which acid has been used to react with which bases. Okay, so salts is being produced from the reaction between an acid with another base. Okay, so it will form salts. Okay, so we have three different types of salts, which is your neutral salts, acidic salts, and basic salts. Okay, so the difference is in the terms of strength of the acid and strength of the bases that being combined together to form that salts in the reaction. If it's a neutral salt, it's a product of strong acid reacting with a strong base. Okay, if it's an acidic salt, it's a product of reaction between strong acid with a weak base, and the basic salt is a product of weak acid reacting with strong base. Okay, so how do we identify either a salt is neutral, acidic, or basic? I'm going to show you afterwards. Okay, so let's try first now understand about salts hydrolysis. So hydrolysis is actually a chemical reaction between anion or cation of the salt with water to yield either H3O plus hydronium ion or hydroxide ion, your OH minus ion, which will determine the final pH of the salts. Okay, so when we are reacting acid and base, okay, both are in equal state. These two will then produce your salts, okay, plus in equals water. Okay, so liquid. So these salts can undergo further hydrolysis depending on the kind of cations and anions that form the salts. Okay, not all the types of salts will undergo further hydrolysis. Okay, we're going to discover more about this when I go down for every type of the salts. Okay, so in a neutral salts, there will no further hydrolysis. So acid and base, and then we form salts and water, so that's it. But if in acidic and basic salts, okay, so these salts will further hydrolyze in water to form either H3O plus or OH minus. So it depends. Okay, so it depends. All right, so let's now first understand about neutral salts. Okay, so neutral salts is a result of reaction between a strong acid and a strong base. So strong meet a strong, another strong. Okay, so it goes to form neutral salt. So examples of strong acid are HCl, and for strong base is NaOH. Okay, in my first video, I already explained to you what is the definitions of strong acid or strong base. Okay, so let's recap. So any strong acid or base, okay, it's the compound which 100% dissociates in water, okay, to yield H3O plus or OH minus. Okay, so depends. Okay, so the reaction between strong acid and strong base will produce your neutral salts. Okay, example given here is HCl reacting with NaOH, both are strong, and it forms NaCl. Okay, so we're going to break down NaCl. So NaCl is made up of Na plus ion and Cl minus ion. So let's look at the potentials of these two ions to hydrolyze or not. Okay, so Na plus in the NaCl comes from strong base. Okay, so from strong base NaOH. okay, whereas your Cl minus from strong acid, HCl. Since both of these, okay, so this is your cation and your Cl minus is your anion. Both are from strong acid and strong base. So these two will not hydrolyze further. Okay, so any anion or any cation that come from a strong acid or strong base will never hydrolyze again in water. Okay, so remember that. Any, I'm going to write it down. Any strong, okay, any cation or anion from a strong acid or base will never ever hydrolyze again in water. Okay, so that's why, okay, for this one, we cannot use the salts to determine what is the final pH of the salts, okay? So the pH for your neutral salts highly depends on the autoionizations of water. Okay, so we already talked about autoionizations of water in our first video. Okay, so what is autoionization of water? Okay, so your water has amphoteric properties. Okay, so a water molecules can act as both acid and base. Okay, so I have, let's say I have these two water molecules reacting with each other. So one of the water molecules will become the acid and another water molecule will become the base. Okay, then it will partially dissociate, okay, forming H3O plus equals plus OH negative equals. So the Ka expression for this one is H3O plus times with the OH negative concentration. Okay, so this one, we don't name it as a Ka, okay, but it's Kw because it's for specifically for water. Okay, so Kw is a constant where the value of your Kw has a specific value according to different temperature. So different temperature have different K value. But we're going to stick, for this one, we're going to stick for the temperature of water to be 25 degrees Celsius. Okay, so at 25 degrees Celsius, your Kw is equivalent to 1 times 10 minus 14. Alright, so H plus equals to the concentrations of your H3O plus is equals to the concentration of your OH minus. Okay, so how are we going to calculate? We'll just simply square root of 1 times 10 minus 14. So you will get 1 times 10 minus 7. Okay, so pH, if you remember, pH is negative log concentration of H3O plus. So I'm going to substitute the concentration of H3O plus that we find here, negative log 1.0 times 10 minus 7, and you will get the pH of neutral salts to be 7. So all neutral salts, okay, the pH of the neutral salts will depend on autoionization of water, because the cations and the anions that made up your salts comes from the strong acid and strong base, which will never hydrolyze again in water. So the pH of the salts highly depends on the autoionization of water, and these are the steps that you need to explain. If let's say the question asks you to explain what is the pH of neutral salts and how do you determine that, okay, and it scores you about 3 to 4 marks. So that means you need to complete your answers with this explanation showing how we derive the pH of neutral salts equal to 7, which is come from your autoionizations of water. Okay, so just to remember, just to remind you, neutral salts come from the reaction between strong acid and strong base. Okay, so cations come from the strong base and the anions come from the strong acid. So when they combine together, it will form a neutral salts, which both the ions will never hydrolyze again in water. So the pH of your salts will highly depends on the autoionization of water. Since water is a neutral molecule, therefore from the Kw calculations, and you get the pH of the water to be 7. Okay, so pH of the neutral salt is also 7. Okay, so let's now discussing on a different salts, which is your acidic salts. Okay, acidic means it's come from your strong acid and weak base. How do I remember that? I look at what kind of salt it's going to produce. Okay, so if it's acidic, that means the strong part is your acid. If it's a basic salts, that means the strong part is your strong base. Okay, so this one acidic means it's from your strong acid reacting with your weak base. Okay, so this is an example. Okay, so weak acid or weak base means it partially dissociates in water, partially ionized in water. So any weak acid or weak base has dissociation constant, which is either Ka or Kb. Okay, so this one we already talked about it in your first video for chapter 7. Okay, so if let's say you're still unclear, you can go back and rewatch your first video of chapter 7. Okay, so I have here an example, which is my hydrochloric acid reacting with my methylamine. So this is my methylamine, which is a weak base. This one is a strong acid. Okay, so this one is my ion, cation, come from my weak base. And this Cl minus, okay, come from my strong acid. Okay, so if we have the hydrolysis of the salts, we're going to break down the ions, okay, in the salts. So we have here CH3 and H3 plus, which come from a weak base. So when it's a weak base, that means this one we name it as conjugate acid. Okay, Cl minus come from a strong acid, so it's negative, therefore it's just an anion. Okay, so your CH3 and H3 plus is the conjugate acid from a weak base, whereas your Cl minus is the anion from strong acid. Okay, so your conjugate acid will hydrolyze further in water. Okay, so how does it hydrolyze further? So CH3 and H3 plus equals plus water. So it will act as an acid. Okay, an acid, that means your conjugate acid will release H plus to H2O or donate H plus. So that means one H and the plus charge will be removed, so leaving out CH3 and H2, okay, equals, and the H plus donated from your CH3 and H3 plus, your conjugate acid, will be accepted by this water molecule, making it to be H3O plus. So in this hydrolysis, we produce H3O plus, which is the properties of acid. Okay, so therefore the salts form is an acidic salts with pH less than 7. Okay, so hydrolysis of conjugate acid in water. Okay, because Cl minus, okay, let's rewrite CH3 and H3Cl. This is our salts that we produce from the reaction between HCl and my methylamine. So equals CH3 and H3 plus Cl negative equals. Okay, so like I said before, any ions come from a strong acid or strong base will never hydrolyze again in water. So your Cl minus comes from strong acid, HCl, therefore it will not hydrolyze again in water. Okay, but it's a different case for your CH3 and H3 plus, because this is the conjugate acid from weak base. Okay, so this one, it will hydrolyze in water. So let's write down the hydrolysis equation for this conjugate acid. So CH3 and H3 plus equals plus H2O liquid, okay, partially dissociate. So it's going to be, so it is an acid, it's going to donate H plus, and your water this time act as the base, so it will accept H plus. So remove H plus, okay? So it becomes CH3 and H. Okay, so from 3 atoms of hydrogen, you donate 1. So minus 1, so it becomes 2. And the plus charge is being removed because we remove H plus, okay? And that H plus is accepted by your water molecule. So water originally has H2, so become H3 and plus charge. So in the progress, we produce H3O plus, which is acidic properties of an acid. Okay, so therefore the pH of the salt is less than 7 and is being classified as acidic salt. Okay? Alright. So let's now talk about basic salts, okay? So basic means the strong one is your strong base. So it's combinations of weak acid with a strong base. Okay, so example here, we have our ethanoic acid, which is your weak acid. Okay, so any organic acid are weak acid. Okay, and then we have this hydroxide of group 2. So this is your strong base. Okay, so you're going to form potassium ethanoate, salts, and water. Okay, so hydrolysis of your salts will release this conjugate base and this cation. Okay, why do I call it as conjugate base? Because it's the ion produced from weak acid. So any weak acid or weak base according to the Bronsted-Lowry, okay, so you're going to produce conjugate acid or conjugate base. Okay, so let's look how we determine the pH of these salts, alright? So if we breaking down our salts, okay, potassium ethanoate, you will have this conjugate base and a cation. Okay, so cation comes from strong base. Strong base, KOH. Therefore, any ions come from strong acid or strong base will never hydrolyze again in water. Okay, so that means you have to refer to the other ion. Okay, so we have here conjugate base from your weak acid. So that means, okay, from weak acid, it will hydrolyze again in water. So the pH of your the pH of your salts here will be determined from your hydrolysis of your conjugate base. Okay, pardon me, this one shouldn't be acidic, but instead it's a basic salts. Alright. Okay, so again, let's rewrite the hydrolysis of your salts in water. Okay, so you're going to produce CH3COO negative plus K plus. Okay, so your CH3COO negative is your conjugate base from weak acid. Okay, whereas your K plus is the cation from strong base. Okay, like I told you before, any ion come from strong acid or strong base will never hydrolyze again in water. Okay, whereas this conjugate base comes from your weak acid, it will hydrolyze again in water. Okay, so let's write down the hydrolysis of your conjugate base. So CH3COO negative equals K plus water. And it's partially dissociates, okay? So you're going to, this one becomes a conjugate base. So as a base, according to the Bronsted-Lowry, it will accept H plus. Whereas your water will become your acid and this one will donate H plus, okay? So CH3COO. So when it accepts that H plus, okay, negative meet another positive, negative plus positive 1, so becomes 0, so no charge. So and then we have CH3COO, H aqueous, okay. Then plus, okay, so these water molecules release the H plus, So it becomes OH minus at the end. So in this hydrolysis of your conjugate base, you produce OH negative. Therefore, the pH of the salts is greater than 7 and it's being classified as your basic salt. Alright, okay. So let's try to do a simple exercise to test your understanding. Okay, so I have here NaCN salts, okay. So NaCN salts, if I break it down, it will have Na plus equals plus Cn negative. Okay, so all Na plus cation which always come from base NaOH. So your NaOH is a strong base, whereas your Cn minus always come from acid named as HCN. So does HCN, okay, hydrogen cyanide, is it a strong acid or a weak acid? So you know which one it is, okay? So Na plus comes from strong base NaOH. Therefore, it will not hydrolyze again in water. Okay, so your Cn minus, okay, comes from it comes from weak acid HCN. Therefore, it will hydrolyze again in water. Okay, so your Cn minus is the conjugate base. This one is a cation. So any ions come from strong acid or strong base, we label it as cation or anion. But if it's come from your weak acid or weak base, we label it as conjugate acid or conjugate base. Okay, so let's write down the hydrolysis of your conjugate base in water. So Cn negative equals act as a conjugate base. So any conjugate base, it will accept H plus according to the Bronsted-Lowry definition. Okay, so reacting with water. So in this time, since Cn negative is your conjugate base, Cn ion, so your water will become your acid. Okay, partially dissociate. So Cn negative will accept that H plus. So HCN, okay, no charge because plus 1 meet negative 1, so become 0. And your water molecule acts as an acid which will donate H plus according to Bronsted-Lowry definition again. So since it's donate, it become OH negative ion. So through the hydrolysis of your cyanide ion in water, it releases OH negative. Therefore, the pH of our salt here, NaCN, is greater than 7. So it's being classified as basic salts. Okay, so we don't set a specific value for your pH because that one involves for you to calculate or by carrying out the experiment. So we just label it as pH equal to 7 for neutral, pH less than 7 for acidic salts, and pH more than 7 for your basic salts. Okay, so let's do exercise 2, which consists of N2H5Cl. Okay, so breaking down N2H5Cl equals, okay, so we have here N2H5 plus equals plus Cl negative equals. Okay, so automatically we know that this anion comes from strong acid HCl. So this is your anion, this is your conjugate acid. Okay, so N2H5 plus is conjugate acid, comes from weak base. Okay, so weak base, how to know what is the weak base? So N2H5 plus, that means it comes from weak base which it accepts 1 H plus. So we have here H5, so minus H plus, so it becomes N2H4 plus H plus. So this is the original weak base, N2H4, which is your hydrazine. Okay, so it will hydrolyze again in water. Okay, so whereas my Cl minus is an anion from strong acid HCl, therefore it will not hydrolyze again in water. So since your N2H5 plus is the conjugate acid which will hydrolyze again in water, so the pH of these salts will highly determine from the hydrolysis of your conjugate acid. Okay, so this N2H5 plus, okay, so let's write down its hydrolysis equation in water. Okay, so it is a conjugate acid. That means it will donate H plus according to the Bronsted-Lowry definition. Since this is an acid, that means your water will become your base. It will accept H plus. Okay, partially dissociation. Okay, so N2H5 plus, remove that one H and plus charge, it becomes N2H4 equals, and that H plus is being accepted by water. So water from 2 hydrogen atom become 3 with plus charge now. Okay, so the hydrolysis of your conjugate acid produce H3O plus. So therefore, this N2H5Cl salt is having a pH of less than 7 and being classified as acidic salts. Okay, I think I already gave you enough exercise and showing you enough examples to make you understand about the types of different salts that we have and how we determine the pH of the salts. Okay, so let's try now your quiz 3, which you need to find out your barium sulfate salts either is acidic, basic or neutral. Okay, so how to answer this? Always start by breaking down your salts into ions, into its ions, which is your anions and cations, and identify which ions come from strong acid or strong base and which ions come from weak acid or weak base. Okay, so any ions that come from strong acid or strong base will never hydrolyze again in water. Okay, but any ions that come from a weak acid or weak base, it will hydrolyze again in water. So the ions that come from weak acid or weak base, it becomes conjugate acid or conjugate base. So these conjugate pairs will hydrolyze again in water, and whatever the products that it yields, either H3O plus or OH minus, will determine the final pH of the salts. Okay, so try to answer this quiz 3 and then you're going to submit it again in the Google Classroom. Okay guys, thank you for watching my salts hydrolysis video. Okay, I hope you already understand the different type of salts that is present and how to explain qualitatively this kind of salts and how to determine its pH. Alright, okay, see you guys again in my next video, which will be about buffer solution. Thank you for watching.